The producers and distributors of Tech AV technical training videos and instructional aids welcome you to this program in the Electric Cable series. This is the overview program in which you will learn some important basic facts about cables and their construction, as well as the basic principles of cable preparation in readiness for a jointing or termination procedure. Other programs in this series will demonstrate the actual procedures for effecting various joints and cable terminations. During the program, you will be given time to review and practice the various procedures discussed and demonstrated. Let us begin then by first taking a general look at cables. Any electric cable can be regarded as a continuous length of current-carrying conductor material designed and manufactured to meet the requirements of voltage and conditions in which it is to be installed. Although many types, sizes and ratings are manufactured, all cables share two common features, namely, they have cores of conductive material and an insulation surrounding the cores. The conductive material most commonly used is copper wire drawn into strands and twisted or laid to create a continuous but flexible core. Wherever flexibility is not required, solid conductors may be encountered. Aluminium, too, is extensively used in the creation of cable conductors, and although comparatively less conductive than copper, it is often used to create such types as house supply lines in low-cost developments. Surrounding the conductive material is a layer of insulation, which is designed to prevent the escape of current from a conductor. Modern materials created for insulative purposes include polyvinyl chloride, better known as PVC, which is a highly insulative and flexible material. PVC is by far the most common type of insulative material used today, especially in the low voltage ranges. Other insulative materials include resin-impregnated paper, as seen here in this medium voltage cable designed for undersurface installation. A material called XLPE is nowadays becoming more and more used, especially in the voltage range of 11,000 volts and upward. Commonly called PEX, XLPE, or cross-linked polyethylene, is an excellent insulative material that is also able to withstand far higher temperatures than other types. Let's look now at typical cable construction principles. All cables are constructed in either single-core design or multi-core design. Single core, the simplest design, consists of a single conductive core surrounded by its insulation material. In some applications, several single-core cables are bundled together to bring in a 2- or 3-phase supply to a development. When brought in on an overhead supply, such a configuration is known as ABC line or aerial bundled conductors. Multi-core cables are those in which 2 or more conductor cores are encased together in one unit. The construction of multi-core cables may be as simple as this so-called flat twin and earth, used mainly in low-cost domestic applications, or as complex in construction as this XLPE medium voltage cable. A very commonly encountered cable is the so-called cab tire type, used extensively for portable power supplies or extension leads at home and in industry. Cab tire illustrates the typical construction of a simple multi-core cable. 3 individual conductor cores are each insulated with color-coded PVC material. The 3 cores are encased with a bedding material which may also be PVC or even silicon rubber. More complex low-voltage cable designs include house supply types, used where permanent supplies are installed. Such cable types are usually of the earth continuity conductor or ECC design, which we will see again later in this program. We have, in passing, introduced two terms which may be confusing to you, namely low and medium voltage. Let's clear this up before we continue. Low voltage is classified as any voltage ranging from 1 up to 1000 volts, or if you prefer, 1 volt up to 1 kilovolt. All domestic supplies are in the low voltage classification, as are the majority of light and medium industrial users. Medium voltage is classified as any voltage ranging between 1001 volts and 36 kilovolts. The majority of medium voltage cabling is used in reticulation systems through underground routing to substations. Certain heavy industries require medium voltage supplies, especially in mining and smelter operations. Let's move on now to describe other aspects of cables which you'll need to know about when you come to perform such tasks as jointing or terminating. Many cables that you'll encounter will be of the armored type. An armored cable is capable of withstanding mechanical loads, such as the crushing load imposed when it is buried under a meter or so of soil. A common method of armoring is for the manufacturer to wind or lay galvanized steel wires upon the bedding, thereby creating a strong, crush-proof layer. Such an armoring type is referred to as steel wire armoring, or SWA, and is used mostly with PVC or XLPE insulated cables. Steel tape armoring, or STA, is another typical type, mostly encountered with paper insulated cables. Most cables, and especially armored cables, are provided with an outer layer known as the outer sheath or outer serving. The purpose of the sheath is to provide a protective covering to the whole encasement. Depending upon the cable's application and working environment, a sheath may be created from PVC, nitrile rubber, silicone rubber, or even a simple layer of bitumenized hessian, or jute as it is often known. The outer sheath, especially with PVC, is a convenient area onto which the manufacturers can imprint certain information, or create a color code to assist the user in identifying the type of cable. So, by way of review, let's strip back a typical 4-core armored cable and examine its construction. Firstly, we have the outer sheath, which, when removed, reveals the steel wire armoring. Earlier, we introduced the ECC cable type. In such a design, some of the armoring strands are in fact designed to be used as the earth-carrying conductor. By carefully observing the armors, you will notice that in this example, 3 strands are made of copper, which, during jointing or terminating procedures, must be connected to provide the necessary earth path. Beneath the armoring layer is the bedding layer, which encases the conductors in this cable type. Each core, within or beneath the bedding, is itself insulated either with PVC, as in this example, or with XLPE material. Let's turn our attention briefly to a typical XLPE insulated cable for purposes of examining certain extra features. Beneath the bedding, or inner sheath, we now have a binder tape which secures all the inner components. Next, there are core fillers. Around each core there is a metallic earth screen, usually made from copper foil. Beneath the screen is a semiconductor tape, sometimes numbered for phase identification. Next is a core screen of semiconductive material that is shrunk tightly against the XLPE insulation. Another conductor screen is found between the XLPE and the conductor core itself. Such a construction is typical of medium voltage XLPE insulated cables. As you can now appreciate, cable construction can and does vary considerably. Whenever you come across a cable that you are not familiar with, our advice is that you consult your supplier or manufacturer's catalog for extra information. Let's break now for a review or discussion with your course controller. Welcome back as we move on to the practical procedures involved in cable preparation for SWA type cables. Most cables require specific preparation whenever they are to be terminated, secured, or jointed. In this section, we shall be demonstrating typical procedures. We stress, however, that whenever and wherever possible, you follow the specific instructions provided by cable accessory manufacturers for the product being used, and the cable stripping dimensions provided. The objective of preparing a cable end is to remove the layers of sheath, armoring, bedding, and insulation in a prescribed way and to specific dimensions. To achieve this result, you will most often need to use both measuring and cutting tools, along with some simple marking out aids. At this stage, it should be mentioned that cutting tools must be sharp, as dull tools end up causing accidents. Sharp knives in the hands of experienced electricians can be used in virtually any situation which involves the removal of PVC or other soft materials. However, if you're not already experienced in the use of a sharp knife, then it is suggested that you perform your cuts as demonstrated, using a cutting board or rubber board whenever practically possible. In virtually all industrial applications, a cable is secured, at the installation, by a cable gland situated at the point of cable entry. For purposes of explanation of principles, we have selected a 4-core armored cable for the supply to our motor. The cable must first be approximated into position at the furthermost terminal, and the point of entry be marked as the starting point for cable stripping. Because we want to work neatly, the entry position is first marked off and a wrap of tape used to provide a cutting guide. With the aid of a sharp knife, a ring cut is made through the sheath against the edge of our marker tape. Care is taken to prevent the blade scraping the wire armoring, as this would dull it. A longitudinal cut is then carefully made, and the sheath peeled away to expose its armoring. Dealing now with the armoring, first we measure off and mark the desired cutting position, which is usually established by a specified dimension depending upon the gland used. A wrap or two of insulation tape at the cutting point is used both to mark the ring cutting position and to help secure the armors during cutting. Note that we do not cut all the way through the wires, as we don't want to damage the bedding layer beneath. To remove the armor wires, one simply bends 3 or 4 wires at a time to break them off at the ring cut. A point to remember when removing the armoring on ECC type cables is to preserve the copper conductor strands by bending them back, thereby preventing them from being accidentally removed. Now we have to deal with the bedding layer, which is first measured and marked to the desired or specified length. A sharp knife is again employed to make a ring cut against the marker. You will require practice to develop the feel required to make a cut without penetrating the core insulation below the bedding. Any damage caused by the knife blade to the core insulation creates a potential hazard, and in terms of the regulations, such damage renders the cable unsafe and unfit to use. A longitudinal cut is next made. This cut, too, must be made carefully to avoid cutting into the conductors. The The cut is not made all the way through the bedding so as not to damage the conductors beneath. Once the cut has been made, the bedding can be peeled off to expose the conductor cores. A properly prepared cable end appears neatly finished and will greatly assist the safety and efficiency of the cable installation into the apparatus. During this program, we have demonstrated some typical procedures of cable preparation using SWA cabling. Other cable types, for example, paper-lead medium voltage cables, and XLPE types do require certain different techniques during their preparation. These procedures will be demonstrated in other programs in this series, dealing with those specific cables during jointing or termination procedures. Practice the preparation of SWA-type cables, as demonstrated, in your own work area to conclude this overview. Join us again in other Tech AV programs, where you can learn more about your chosen trades.